Hello friends, welcome again. Today we will be solving a question related to machine, and the question is the DC shunt motor takes armature current of 50 amps and at a rated voltage of 240 volts. Its armature resistance is 0.2 ohms, and then we insert a resistance, external resistance of 1 ohm in series with armature, and the field flux remains unchanged. So he's asking the percentage increase or decrease in speed for half of the load torque. Okay, so for this case, the uh, electrical diagram can be drawn like this. Okay, the first case you can see that the field winding is in parallel with the uh, armature. This is a typical in shunt machine. Okay, so you can see an armature resistance of 0.2 ohms here. Okay, and in the second case the resistance which was inserted is this R external is equal to 1 ohm. It is inserted in series with this armature. Okay, now to solve this problem we have to look into some relations. So these are the relations which are applicable for any kind of DC machine, where EB is proportional to the product of flux and speed of the machine. Okay, where phi f is the flux and n is the speed. And the second relation is tau is proportional to phi f into Ia. Okay, so this is the second relation we need to consider. And in this case, in our case, the shunt machine, where the field flux is constant. Okay, hence this relationship can be again rewritten as EB is proportional to n and tau is proportional to Ia. This is what we'll be using in our question today. Okay, because the flux is constant, hence it's only EB is only proportional to n. Okay, and tau is proportional to the armature current. Okay, so let's start. So now let us say that the armature current before inserting the resistance was Ia, and after inserting the resistance was Ia2. Same torque was tau 1, and after inserting it was tau 2. Same back EMF before inserting was EB1, and after that it was EB2, and speed was N1 before, and after that it became N2. So for the first relation we can use is this thing. Okay, where he says tau 2 has to be half of tau 1. Now we know that tau 2 is proportional to Ia2. Okay, and tau 1 will be proportional to Ia1. So tau 1 over tau 2 is equal to Ia1 over Ia2. Okay, now you know that tau 2 or tau 1 is going to be twice tau 2. Hence we can use this relation and put it in this relation, and we get twice tau 2 over tau 2 is equal to Ia1 over Ia2. So if you solve this, you get Ia2 is equal to half Ia1. Okay, now before inserting resistance, Ia1 was 50 amps, so Ia2 goes to 1 by 2 into 50 is equal to 25 amps. So this is for our second relation. Now after doing this, we need to find a relation between our speed, and that can be done by using our back EMF, because EB is proportional to n. Okay, so what we can do is we can use KVL. Okay, before inserting resistance. Okay, and we can use this figure. With the help of this figure we can do that. So if you write KVL, it is going to be 240 is equal to, okay, 50 into 0.2 plus EB1. Okay, now if you solve this, you get EB1 is equal to 230 volts. Okay, so this is what we get. Okay, now once we get EB1, let us do it for the case after inserting the resistance. So after inserting the resistance, you can see that 240 volts is going to be this current Ia2 into 1 plus 0.2 ohms. This is the external resistance and this is the armature resistance plus EB2. But we already calculated Ia2 as 25 ampere. So 240 is equal to 25 into 1.2 plus EB2, sorry. So EB2, if you calculate from here, it comes out to be 210 volts. Okay, so now we have our EB1 and EB2. So EB1 would be proportional to N1 definitely, and EB2 will be proportional to N2. Okay, as we discussed earlier. So EB1 over EB2 is equal to N1 over N2, and EB1, if you put the values, it's going to be 230 over 210. Okay, so now you can see that we have a relation between EB1 and EB2. Okay, it is the N1 over N2 is equal to 230 over 210. Now if you calculate N2 from here in terms of N1, you will see that N2 is 210 over 230 into N1. Now this fraction is going to be less than 1, hence N2 will be less than 1. Okay, hence the speed N2 is less than N1. Okay, so we can say that the increase options, that is option A and B, can be discarded directly. Okay, now we are left with only option C and D. So decrease in speed, okay, what can we write for decrease in speed? So decrease is equal to, if we say that N1 was the speed earlier, so N1, that is the speed earlier, minus N2 over N1 into 100. Okay, so it will be in percentage decrease. Now N1, we keep it as it is. N2 is 210 over 230 into N1 over N1 into 100, and if you calculate this, it comes out to be 8.7%. okay, which matches with option D. So there is going to be a decrease of 8.7%. okay, so this is how you need to solve for the questions related to the resistance when they are inserted in series with the shunt motor. Okay, so thanks for watching.